Chapter 8: Smart Contracts in Viper. Viper is an experimental, contract-oriented programming language for the Ethereum virtual machine that strives to provide superior auditability by making it easier for developers to produce intelligible code. In fact, one of the principles of Viper is to make it virtually impossible for developers to write misleading code. In this chapter, we will look at common problems with smart contracts, introduce the Viper contract programming language, and compare it to Solidity, demonstrating the differences. Vulnerabilities in Viper. A recent study analyzed nearly 1 million deployed Ethereum smart contracts and found that many of these contracts contained serious vulnerabilities. During their analysis, the researchers outlined 3 basic categories of trace vulnerabilities. 1. Suicidal contracts. Smart contracts that can be killed by arbitrary addresses. 2. Greedy contracts. Smart contracts that can reach a state in which they cannot release Ether. 3. Protocol contracts. Smart contracts that can be made to release Ether to arbitrary addresses. Vulnerabilities are introduced into smart contracts via code. It may be strongly argued that these and other vulnerabilities are not intentionally introduced, but regardless, undesirable smart contract code evidently results in the unexpected loss of funds for Ethereum users, and this is not ideal. Viper is designed to make it easier to write secure code, or equally to make it more difficult to accidentally write misleading or vulnerable code. Comparison to Solidity. One of the ways in which Viper tries to make unsafe code harder to write is by deliberately omitting some of Solidity's features. It is important for those considering developing smart contracts in Viper to understand what features Viper does not have and why. Therefore, in this section, we will explore those features and provide justification for why they have been omitted. Modifiers. As we saw in the previous chapter, in Solidity, you can write a function using modifiers. For example, the following function, changeOwner, will run the code in a modifier called onlyBy as part of its execution. Function, changeOwner with one parameter, address, new owner. Public, onlyBy invoked with one argument, owner. Open brace, owner equals new owner, close brace. This modifier enforces a rule in relation to ownership. As you can see, this particular modifier acts as a mechanism to perform a pre-check on behalf of the changeOwner function. Modifier, onlyBy with one parameter, address, account. Open brace, require message.sender equal to account, underscore, close brace. But modifiers are not just there to perform checks, as shown here. In fact, as modifiers, they can significantly change a smart contract's environment in the context of the calling function. Put simply, modifiers are pervasive. Let's look at another Solidity-style example. Enum stages, open brace, safe stage, danger stage, final stage, close brace. uint public creation time equals now. Stages public stage equals stages.safeStage. Function next stage with no parameters. Internal open brace stage equals stages called with uint of stage plus 1. Close brace. Modifier stage time confirmation with no parameters. Open brace if stage equals stages.safeStage and now is greater than or equal to creation time plus 10 days. Then invoke next stage. Underscore, close brace. Function, a with no parameters. Public, stage time confirmation. Comment, more code goes here. Open brace, close brace.